Hi, my name is Daniel Sauer. I'm in the Intro to Statistics online class. Here's my UCID. My M number is M103092220. So for the first question in the exam, it asks, in this study, two independent random samples with interval ratio data were collected. In group 1, a random sample of 133 primary hypertension patients were taken, and each person's total cholesterol was recorded. In group 2, a random sample of 41 normotensive was taken, and their total cholesterol was recorded. Data are given in the table below. Use 5-step hypothesis testing process to check if the pH group's population average total cholesterol level is significantly higher than 210. Use alpha is equal to 5%. So the first problem, and the way I went about solving this, is I wrote down all of the givens that we know. So the sample mean X bar is equal to 214.71. Population variance is equal to 879.49. Standard deviation is equal to the square root of the variance, which is the square root of 879.47, and that gives us a value of 29.66. The sample size N is 133, and the alpha angle, is 5%, but in this case we use that value to be 0.05. So for the first question, we are determining the null hypothesis. So we're finding it's greater than 210, and the null is less than or equal to 210. So for the second part of the equation, we are looking to find the rejection area. And we use our table to find the critical score, which after looking, the critical value is 1.64, and it rejects the region Z because Z is greater than 1.64. And in part 3 of the question, we need to determine the test statistic. So the test statistic, the formula is Z equals the sample mean minus the assumed mean all over the standard deviation divided by the square root of N. So that ends up working to be 214.71 minus 210 all over 29.66 divided by the square root of 133. And our test statistic value for this question is 1.831. So from here, the next step, we need to decide if our null hypothesis is either supported or denied. So we need to plug into the table the Z value for like the normal distribution chart. So 0.035 is 5 is greater than 0.035. So we reject the null. So in conclusion, there is enough evidence to claim the population mean is greater than 210 at a significance level of 0.05 or 5%. So for the second question, it reads, in this study, two independent random samples with interval ratio data were collected. In group 1, a random sample of 133 primary hypertension patients were taken, and each person's total cholesterol was recorded. In group 2, a random sample of 441 normotensive was taken, and their total cholesterol was recorded. And then the data is given in a chart below for the values of pH and NT. So the first part of the question asks, what is the point estimate of the primary hypertension patient's total cholesterol mean? So for the first part, the point estimate formula is the sample mean of pH minus the sample mean of NT, which is given by 214.71 minus 193.2. And the point estimate for this question is 21.51. So find the standard of error of the sample mean of the primary hypertension patient's total cholesterol. So this equation is given by the square root of the standard deviation squared of the first value divided by the sample size of the first value. And then you plus the standard deviation squared divided by the sample size squared of the second. So that comes out to working, that formula ends up coming to be the square root of 29.66 squared divided by 133 plus 33.04 squared minus 49. And that standard error value is 5.765. So then the third part of the question asks, can you apply the central limit theorem to estimate the population mean of the primary hypertension patient's total cholesterol? And if so, why? So for this, we need to look at both sample sizes. Since they're both greater than 30, we can use this central limit theorem because that's one of the parameters. So then the next part of the question says find a 90% confidence interval of the population mean of the primary hypertension patient's total cholesterol. Also interpret this meaning. So since we know that the point estimate is plus minus 2 times 1.645, which we get from the normal distribution chart divided by 2, we find that value, we find that value from the chart. And then we take that and we multiply it by the standard error that was calculated earlier in the problem also. So for this, we do the point estimate plus 1.645 times 5.765 for the standard error, which comes out to be 30.993. So from this, we can conclude that we are 90% confident that the difference in the population will fall between 12.027 and 30.993. So for the third and the final question, it reads, a small sample study is conducted involving 15 infants to investigate the association between gestational ages at birth, and that's the X value in the chart, measured in weeks, and birth weight, and that's the Y value in the chart, measured in grams. So for the first question for the final question, it says calculate the Pearson's sample correlation coefficient and interpret its meaning. So for the first one, we have to determine strong lines relationship or not, with stronger relationships being closer to 1 or -1. So Pearson's sample calculation coefficient is equal to n. So I got this value actually from an Excel function, which gives us the correlation coefficient of 0.8793. There is a positive correlation between gestational age and birth weight. When age increases, then birth weight increases. So for the second part of the problem, we are calculating the null hypothesis. We are calculating the null hypothesis. So for this one, the second question reads, test the hypothesis, h of 0 is equal to p xy equals 0 for the right tail alternative at 5% significance level. So the test statistic is equal to the sample size, the square root of the sample size minus 2 times the sample correlation coefficient, which we calculated in the first part of the problem, divided by the square root of 1 minus the sample correlation coefficient squared. And that comes out to be the square root of 13 times 0.8793 divided by the square root of 1 minus 0.8793 squared. And the test statistic for this problem ends up coming out to be 6.6566. So we can conclude that the critical value of T using DF and 5% significance is TC, which is the critical value, is equal to 1.771. since t is greater than t of 0, the null hypothesis is rejected and the population correlation is positive. And then for the third and final part of this question, it says fit the line of best fit of y on x. Use this model to estimate when x equals 18. So for this, we use the equation y equals a plus b. So first we need to find b. So we do this by multiplying the sample correlation coefficient r times the standard deviation of y divided by the standard deviation of x. So this is 182 divided by 472. So then the second part is we need to find a. We can do this by the y bar minus b times the sample mean x bar. And then we find this a value to be minus 4070.57. So finally we plug in. So this creates the equation that is y is equal to 182.15x minus 4010.6. So the next value, we need to plug in 18 for the x value. So that is y equals 182.15 times 18 minus 4010.6. And our y value comes out to be negative 732.6 or 0.38. So thank you. I enjoyed taking your class. All right, thanks.